Hi everyone, so for today's video we are going to solve LeetCode problem number 3186, maximum total damage with spell casting. Okay, so we are given an array called power where each element represents the damage of a spell, where there could be multiple spells that can have the same damage value, and we need to decide which spells to cast. And for example, if we cast the spells with power of I, we cannot cast any spell with range from power of I minus 2 till power of I plus 2. And we need to return the maximum possible damage that we can cast from the power array. Okay, now let's take a look at the first example. So in here we are given an array power with values of 1, 1, 3, and 4. And the output is 6. Basically, the maximum possible damage is 6, which is produced by if we choose casting spells with power of 1 and power of 4. And if you can see in here, if we choose the spells with uh, damage of 1 or with power of 1, sorry, we cannot choose the spells with power of 3 because the power of 3 is not higher than power of 1 plus 2, which is we need to take, we can only take 4 in this example. And also another insight is as you can see that we have duplicate values in here, 1 and 1. And if we choose 1 in here, we can actually cast the both spell. So it will return us the damage of 2 in here. And 2 plus 4 is 6. Okay, now let's derive the intuition from the description and the example. So first one is, if you have n spells with the damage of x, you will give the damage of n times x. Yeah, as we discussed before, if we have, for example, in here, we have two ones in here, and we choose 1, we could cast damage with 1 times 2, which equal 2. We could cast 2 damage in here. And the second one is quite obvious from the description. If we cast a spell with the damage of x, we cannot cast any spells with the damage of x minus 2, x minus 1, x plus 1, and x plus 2. Let's discuss the first intuition. So, how we can efficiently compute, for example, if we take the spells with power of 1, how can we efficiently compute its damage is we can create an counter. So, we could create a counter called frag, which return the frequency of the items or the power. So 1 will have 2 items, 3 will have 1 item, and 4 will have 1 item. And yeah, I could also create an array in here, which is contain the unique element of power 1, 3, and 4. And yeah, if you see this, you can actually translate this problem into called tag or no tag problem. What I mean is, let's say that we are in here, we are at index I, and in here we have a two choice. We either can take 1 in here and move to the next element that is greater than plus 2, of course, or we could skip 1 and move to 3. In the optimum solution, we choose 1 and we move to the next element that is greater than 3 or 1 plus 2, and we move to 4. If we decide to choose 1 in here, we will have damage of the spells I times the frag of spells I. So yeah, if we take the 1, it will return us 1 plus the frequency of 1, which is 2. 1 times 2 will be 2. And we move to the element where it is greater than 1 plus 2, which is 4. And we calculate the damage of 4. And it will return the optimum solution or optimum damage, like in the example. So yeah, we could translate this problem into tag or no tag problem. Okay, in here I already create addition tree, so we can deep dive into the solution, how it works. Initially, we will start at index of 0 and the damage will be 0. So in here we have the choice, either we take the spells at index 0, which is 1, or we could also skip 1 and move the index I to the next index I plus 1 to the 3. If we decided to take the spells at index 0, we need to increment the damage by the power of that spell times the frequency of the spell. So it will be 1 times 2 will return us 2, so we increment it by 2. Also, we need to move the next index to the element that is higher than the current power of spells plus 2, which is 1 plus 2 is equal 3. So we need to find the next element that is higher than 3. There are two choices on how we can find the next element that is higher than spell type plus 2. The first one is the obvious one. We could use for loop. So what I mean is, let's say we have pointer j in here. So we check one by one on the next element if it's higher than 3. Check in here. 3 is not higher than 3. We move to the next element. 4 is higher than 3. So 4 at index 2 will be our next index in here. So we move to the index I plus I is equal to. And the second approach is by using binary search. Since the array is sorted in here, the spell is sorted, uh, we could use binary search to find the next element that is higher than spells I plus 2. And since the problem is actually only plus 2, it might be kinda over engineer solution to use binary search, since this one is will only take O times k. For example, like this is k is equal to, it will only give us the same complexity. So binary search will return us the complexity of log k will be log 2. So it doesn't make any difference for both of the approach for this specific problem. But what if the question were changed? What if the k is a very high number, like 1000? In this case, maybe the binary search will be the most optimum solution, since we will cut the complexity to log k. And thus, so for this problem, I will still to choose binary search, so we can go for more generic approach. And yeah, so basically, yeah, that's it for the choice at every index. And also, if you take a look in here, we did some duplicates computation. For example, in here we compute at index I is equal to. In here we also compute at index I equal to. So we could do some kinds of memoization in here to store the computation, so we don't compute the same stuff twice. So we will get a memo index, and memo I will be actually defined as the maximum damage we can cast start at index I. And by doing this, we can cut the complexity more. So initially, if we don't do memoization, the complexity will be 2 power of n, because at every index we have to choice, and it will be grow ledger to 2 power of n. And if we do the memoization, it will cut the complexity to the O power of n. So the overall time complexity will be O of n. Specifically O of n times log k is 2, so it didn't matter. So yeah, we could say that it's O of n. And for the space complexity is, it will be also O of n, considering the memo array and the recursion stack that we will use. So this is for the overall complexity for our solution. Okay, now let's jump on how we can code the solutions. First, we need to create the frequency map. So it will be containing the frequency of each power. And we need to create array, I will call it spells. It will containing the unique power sorted in ascending order. Sorry. And next we need to create a memoization object. It could be an array or hash map. I will choose hash map. Next we define the recursive function in here. The parameter will be index with integer, and the return will be returning the maximum damage that we can cast if we start at index I. So it will be integer. And we need to write the base case. So for the base case, if the I is higher or equal length of spells, then we return 0. If I in memo, then we return the memo value. And in here we have two options. Option 1 is we skip I and move to I plus 1. So basically we didn't take the spells at index I, then we move to I plus 1. And at option 2, we take spells at index I and move to the next index where spells at index next I is higher than spells I plus 2. Again, there are two choices. Either we use binary search or we use for loop. For this problem, we will use binary search. We need to calculate its damage. The damage if we take I is the power of spells I incremented by the frequency of that power. And in here, we calculate next I. I will use the built-in method from Python, basic, right? Basically, it will give us the next element where the element is greater than spells defined in here, spells I plus 2. If you want to see the solution without the built-in method, you can check the caption. I will give a link in there. And in here, the value will be the damage plus DFS next I. But if, for example, if we add in here at index 4, there will be no next element. In this case, the next I will be equal to the length of the spells. So we add in here if the next I is equal the length of spells, which means there are no next element. There is no next element. So we returns the damage. Only to compute the next element. And in here we store the value. We will take the maximum of not tag and the tag. And we return the value of memo. And yeah, we will start with at 0 position. Let's test the result. Okay, what did I did wrong? Oh, sorry, there's some mistake. This should be less than spells. Yet, it's correct. Now let's submit the solution. Okay, so the solution are getting accepted. If you want to get like the most optimum solution, you could translate this problem into bottom-up solution, and you actually didn't need to use bisect or binary search in here. You could just for loop because the restriction is only spells I plus 2. Okay, so that's it for today's video. Hope you guys like it. Please have to subscribe and likes if you want. Thank you.